Question 15. The table shows the melting points of two chlorides. So we've got sodium chloride with a melting point of 801 degrees C, a very high melting point, and we've got carbon tetrachloride, CCl4, with a melting point of -23, so a low melting point. A student concluded that ionic bonds are stronger than covalent bonds. Do you agree? And explain your answer. So this question, we've got the word bonds in here. It's about bonding. It's also about structure. So to answer this question, we have to think about the structure of both of these substances. Sodium chloride, you should know from the fact that that's a metal and a non-metal, that that is an ionic structure. Carbon tetrachloride, two non-metals, covalent, very low melting point. We should recognise that that must therefore be a molecular structure. If we think back to what both of these structures look like, I've got an example of the sodium chloride structure on the left here and the carbon tetrachloride structure on the right. So, does this information tell us whether ionic bonds are stronger than covalent bonds? We've got to think about what type of bond is broken when each of these structures melts. So we've got our sodium chloride structure consisting of positive and negative ions in what we call a lattice structure. For this structure to melt, so this is a solid in the way it's drawn at the moment, for this structure to melt and these ions to become free to move, we have to break these ionic bonds, so the force between the positive and negative ion. However, in our covalent molecular structure, we've got strong covalent bonds within the molecule. But what we've also got to remember is that what's actually holding these substances, these covalent molecular substances together when they are a solid, is not the covalent bonds. There's no covalent bonds between the separate molecules. What's holding these substances together as solids is what we call weak intermolecular forces, and we often represent them with a dotted line. So when our covalent molecular substances melt, it's not the covalent bonds, these strong bonds within the molecule that break. It's these weak intermolecular forces that exist between the molecules. So to sum that up in an answer, do we agree that ionic bonds are stronger than covalent bonds? No. You shouldn't agree with that. You should know that both ionic and covalent bonds are strong. And that's part of my explanation. So both ionic and covalent bonds are strong. When sodium chloride melts, strong ionic bonds are broken. This requires a lot of energy, hence the high melting point. When carbon tetrachloride melts, only weak intermolecular forces of attraction are broken, not covalent bonds. Weak forces require less energy to overcome, hence the low melting point.